Students, greetings. I hope all is well. This is Electricity Screencast 1. Please answer these questions Cornell Notes style so they're ready for the beginning of class tomorrow. I will check them. Okay, so let's get into it. Electricity. Electricity is the movement of electrons, okay? And so here what we have is a circuit, and we've got battery, and we've got within, everything has electrons inside of it, right? And by using a battery, we can get those electrons to move, and when those electrons begin to move, they can do work, right? They can generate energy, and the movement of those electrons is electricity. Electricity is really useful in the 21st century because it can be created by pretty much any type of energy, right? So mechanical, light, thermal, all different kinds of energy. It can create electricity, and electricity can be converted into almost any kind of energy. I see it says and. Oh well. All right. So we went through this earlier today, and we talked about the power source, the conducting path, and the load as being the kind of main parts of a circuit. And we're going to go through each of those parts. So the power source, that would be referred to as the voltage. Okay. And so the power source comes from a battery or a generator, right? That's like what's pushing the electrons. That's what's making the electrons move, right? And it's measured in volts, okay? And volts is a measurement of electrical potential energy. So just like gravitational potential energy or chemical potential energy, if you have a lot of volts, if you have a lot of electrical potential energy, then you can convert that potential energy into other kinds of energy. So if you have a huge battery, it's like having a huge mountain and pushing something down that mountain, right? If you have a really big, strong battery, you have even more electrical potential energy, which means that you can get even more energy out of that battery. Okay, so hopefully that makes sense. Electrical potential energy. So the conducting path, the current. The current is the flow of electrons, right? So this is like really, when we think about electricity, this is what we're thinking about, right? The power source pushes the electrons, but the flow of electrons itself, that is the current. It's measured in amps, right? And amps is measuring like the amount of electrons flowing through a circuit per second, right? So if I've got my example here and I build a circuit really quickly, and we've got our light bulb. Okay, and we connect it. Now you can see the electrons are moving, and so how fast they're moving is determined by it is how much current there is. Now watch, if I increase the voltage, if I increase the amount of potential electrical energy, the electrons move faster, right? And now we have more current. Okay, now getting back to this, the last thing is the resistor, the load, right? The thing that is using the electricity, and these are called resistors, right? So resistance is when the electricity flowing through the current is used to do something, right? So when you charge your phone, when you turn on a light bulb, when you have a fan or a microwave, all of these things are resistors, right? They're using that electricity to actually do something. Okay, and so resistance is measured in ohms, all right, and that just is a measurement of how much like electricity is being used. So the more ohms something needs, like the more ohms like a amplifier for a guitar has, that means it needs more, like a bigger power source, a bigger battery, and stuff like that. Okay, just really quickly, you can see that you get more light out, right, if you get more current. Okay. Finally, we come to what we call Ohm's law, all right? And I like this drawing here. Volts are like what push the electrons. Amps is like the current, and ohm is like the thing that's like sucking out the electricity, right? And so this cartoon kind of sums up everything. But we have this equation, right? It's voltage equals resistance times current. This is Ohm's law. It's like really fundamentally important to electrical engineering and stuff like that in the study of electricity and physics. And pretty much it's really simple, right? It's like the triangle. I bet you can make a triangle if you're wise. I would make a triangle, but if we have a resistance of 5 ohms and a current of 5 amps, then you multiply 5 times 5 and you get a voltage of 25, right? So you can, if you know 2 of these, you can always calculate the third. Okay? Last thing, conductors versus insulators. Conductors allow electricity to flow, so like wire. Insulators prevent electricity from flowing. So what is something that, if you were working with electricity, what would you want to wear? Maybe like rubber gloves or something like that. So those are things that are insulators. Hope this all makes sense, and good luck, and I'll see you tomorrow.